Today's topic is applications of all the trig ratios. We are near the end of the unit, so we're going to put them all together. You can use a date of May 12th. And this is what our notes look like today. Nice and short. With any word problem, one of the biggest things you can do is draw a picture. So we're going to draw the right triangle and we're going to identify the things that might be missing in the problem. If you want to enhance your picture by drawing a tree or drawing the boat in the water, you can do that. We want to take the information in the problem and label the sides and angles with whatever's provided in the problem. Keep in mind you're looking for certain keywords. Are they talking about a vertical distance or a horizontal distance? Think about what you know of the world and make good choices. Again, like we know a ladder wouldn't be pushed flat up against the wall, the ladder would be leaning. If you zip line, we're not dropping straight down, we're going down on a slant. So place your pieces accordingly. We want to assign a variable to whatever is missing. Could be an angle, could be a side. Once everything's labeled, we want to see what's present and we want to pick the correct trig ratio. And it could be sine, cosine, or tangent. And if they give you a lot of information, it could be any of those options. So where I might pick tangent, you might pick sine. Ultimately, we want to sub in everything we know. If it's a proportion, we'll cross multiply. If it's an angle measure missing, we will use our inverse procedures, and we want to find whatever's missing. So in example 1, it says at a point on the ground, 20 meters from the base of a flagpole. So logic tells us the flagpole would be vertical. So let me set my triangle up. So we're 20 meters on the ground. So that's going to be our horizontal distance. The measure of the angle of depression. So when they say that, we know that someone's up high looking out. So I drew the line to represent the angle of depression, and it's 29 degrees. We know that we can't use the angle of depression because it's not in the triangle. So we're actually going to flip it down inside the triangle and make it an angle of elevation. They want us to find the height of the pole to the nearest meter. So again, the pole is your vertical distance. Keep in mind, you are here at 29. How am I going to classify my sides? X, the missing side, is opposite the angle. It's across from. And 20 is adjacent to or touching the angle. So that will be adjacent. Opposite and adjacent tells me it's the tangent ratio. So we'll do tangent of 29 equals opposite over adjacent. We can make this a proportion so that we can cross multiply. When you set this up, it'll be tangent of 29, close your parenthesis, and then do times 20 or put 20 in parentheses. And then when you enter this into the calculator, it's important that you put the parentheses in there as well, or you will get some kind of wonky answer. We're going to round it to the nearest meter, so that flagpole is about 11 meters tall. In example 2, it says a theme park has a pool slide with a vertical height of 257 feet. Now the slide itself is not the vertical distance, but the support holding it is going to be 257 feet. So that is my vertical distance. The slide has a length of 350 feet. So obviously I'm going from the top down. So there's my slide. We want to find to the nearest degree the angle the slide makes with the ground. So that's my unknown angle of elevation down at the bottom. So again, I'm here at X. We're going to identify our sides. So across from my angle is 257. That is opposite. And 350, even though it's touching this side, 350 is across from where the right angle would be. So this is the hypotenuse. Some old hobo. So we want to use sine of X equals opposite over hypotenuse. When you're looking for an angle measure, we use our inverse function. So this will look like inverse sine. The X and the ratio will switch places. And then we want to type this into our calculator or our iPad. If you throw a decimal on 257 or 350, you'll get a decimal answer, and it should be about 47 degrees. Make sure your calculator is in degree mode before you start. In example 3, it says Bobby is standing on a cliff 1,050 feet above the ground and plans to paraglide to the bottom of the canyon. Okay, so let's set up our triangle. He is up here at the top of the cliff, and that's 1,050 feet above the ground. When he paraglides, he's going to go down on an angle. So it says the angle of depression looking out over the canyon is 83 degrees. So angle of depression, we're going to switch and make it angle of elevation. How far will he travel from the top of the cliff to the bottom of the canyon? So we're looking for that diagonal distance, x. I'm inside the triangle at 83, so the 1,050 is opposite me. And again, x is across from where the right angle would be. So even though it's adjacent to this, the hypotenuse wins. So this will also be the sine ratio. So we'll have sine of 83 degrees, opposite over adjacent. It's okay for the x to be in the denominator. I'm going to make it a proportion. So when I cross multiply, it'll be sine of 83. Make sure you close your parentheses. Times x equals 1,050. We're going to divide both sides by sine of 83. And those will cancel out. And you can enter your ratio here into the iPad. And I get a value of 1,057.89 meters. It doesn't tell us how to round it, so you can leave it unrounded and give me the exact answer, or I rounded it to 1,058 meters. Tonight's homework is number 121. You'll see these problems in your home packet. I'll also send a digital copy. Make sure you draw and label a diagram. That's worth a point, and then the solving of it is worth a point. If you can't figure out how to set up your opposite, adjacent, and hypotenuse, please make sure you email me. I'm happy to help you. If you have any questions, please get in touch with me. Otherwise, have a great day.